Okay, good morning class. So at this point we're looking at Euclidean geometry. We looked at this point at the similarity proof. And of course I won't be doing the proof in this video. However, the link to the proof will be found in the description box below. Okay, this theorem is normally worth 6 or 7 marks. Okay, so let's look at example 8, and example 8 is on page 261. Example 8 is on page 261. Okay, so in example 8 we are told in triangle PST, which is the big triangle here, PST, which is this triangle here. We are told that ST is perpendicular to PS, which means to say that is 90, and RQ is perpendicular to PT. The question says we are required to prove that triangle PRQ is similar to triangle PST. Okay? So when we prove similarity, okay, or congruency, we start off as follows. We say in triangle PRQ and triangle PST. We don't start off by saying that the two triangles are congruent or similar in this case. You can't start off like that. Okay? So if they ask you to prove congruency, we say in triangle PRQ and triangle whatever. Prove similarity, we start with the same one. If you leave it out, you won't lose it. Okay. Now to prove similarity, we prove two angles of the two triangles are equal. Automatically, the third one will be equal. If you look at it, if you got two triangles here, and you got 60, 20. You got 60 and 20 there. What is the size of this angle? 100. And if you look at this triangle, what's the size of the triangle? Also 100. Why? Because the angles in the triangle adds up to 180. Okay? So if you can prove that two angles are equal, automatically the third one will be equal. Hi boss. Come say.
Mind if I talk to
Yeah?
the people?
Did you guys get it?
Haven't seen me yet. Morning, I'm running down these letters.
Okay. So if we can prove that two angles are equal, automatically the third one will be equal, or the two triangles. Okay. So looking at the two triangles in question, it's going to be PRQ. So PRQ is that triangle here, and PST. So what can we say about those two triangles? Which angles are equal? First, angle P is in both triangles, not so. So what do we say? Angle P is your common angle. If we use common angle or common side, you must say common side or common angle. You can't just say common. Okay. Or you can say angle P is equal to angle P. Okay. Or you can say that angle TPS is equal to the angle RPS, whatever. All of that is acceptable. Okay. Secondly, we need another angle that is equal here. Yes? R1, yes? Is 90, yes? Which is also equal to? Okay, now you see that was given perpendicular here. RQ? No? TS? PS. Is it this one? RQ? Yeah. RQ and PT. So that 90 could have been there, or it could have been at R1. Can you see that? So do I have to say R1 is 90 angles straight line? No. Because that's already said clearly. Okay? So I can say simply that angle R1 is equal to? Can I just say S? There are many angles there at S. No. You're going to lose the mark. You can't just say S. It's going to be safer for you to say PST or TSP. You don't know who's going to mark your paper at the end of the year.
So one say is 1 plus
Is 1 plus is 2? Yes, that is fine. Is 1 plus is 2? Or is 1 plus is 2? Or PST or TSP is all the same. Okay? But don't make up your own stuff and just say is. Okay? One examiner might accept it and the other wouldn't. Okay? Can we afford to lose a mark here? No. There's many other places we will be losing our marks. Not so. No, you're supposed to be saying. So P is T. So now what we have? We have two angles we proved already to be equal. So automatically the third one will be equal. Okay. So it's going to be, what's the third angle in PRQ? Q2. And in PTS? Angle T.
Wait. So now can we say T?
Why can you just say T? Only one angle at T. Okay. So I can say in the third case, therefore, angle Q2 is equal to angle T. Why? Because that's the third angle of a triangle. Oh yeah, what's the reason why R1 is equal to, okay, this is equal to 90. Forgot to put the 90 in. Is that enough information to conclude similarity? Yes. So what do I say here? I say therefore, triangle PRQ is similar to triangle PST. Why? Angle, angle, angle. We prove similarity using three angles. Okay? Does it make sense? Any confusion? Yes, Michael? No. To prove similarity, either you prove three angles are equal or the sides are in proportion. One of the two. You don't mix and match here. Okay. Anything else? Okay. So what I'm going to do is I'm going to take what I've written down now, or from the board, because I want to keep the diagram in focus here. Okay. Okay, that's going to be behind the calculator. So rather not. So in A, we have proven that triangle PRQ is similar to triangle PST. Right. Let's go with B. Now, after a similarity proof question, okay, we have to prove two triangles are similar. Always after that you'll have a distance question. Most of the time, or if not all the time. If there's a question after a similarity question, in rest assured it's going to be a distance question. As you can see here, B and C are distance questions. Okay. So if it is that PRQ is similar to triangle PST. Okay, also, before I forget to mention that you must check that the triangles are in order, in the right order. So P was equal to P, angle R of this triangle was equal to angle S, and T and Q was equal. Okay. The order has to be in the proper order so that the corresponding sides will be in proportion. So I say PR over PS is equal to RQS over ST equals PQ over PS. Why? PT. Why? Because the triangle PRQ is similar to triangle PST. Or you can say sides are in proportion. Okay? Now we look at, they want RQ, where's RQ? Yep. They want PQ, yep. They want ST, yes, and PT. Can you see that? So what can we say from here? So RQ, is RQ over Q? No. So I can interchange that. Remember when we did that cross multiplication, all that? Those two can interchange. So therefore RQ, so RQ, I'm writing PQ, RQ over PQ is equal to ST over PT. Therefore RQ is to PQ as ST is to PT. Remember what did we say yesterday? Another way of writing a fraction is as a ratio, because fractions are ratios. Okay. This is another way of writing it. Sorry? No, because this is the manipulation of or cross multiplication that's taking place. So no reason is required. Only when you're using a Euclidean geometry application of a theorem do we state the reason. Okay. Anything else? Right. So what I'm going to do is I'm going to take B off. Okay. So now we're going to look at C. C says PR, some people. So again we know that PR over PS is equal to RQ over ST equals PQ over PT. Okay. Remember this was on your book already. Okay, triangle PRQ. So you don't have to repeat it again. But I took it off already. Okay. Right, so what are they looking for? They're looking for PR, PT, PQ, and that. Can you see that, people? So what do you notice? It's being multiplied. So from there, I can take this out. I don't need that there, the middle one. So I cross multiply. So that will simply give us an answer of, therefore, PR times PT is equal to PQ times PS. There we have proven what they gave us. Okay. Any questions here? No? Yes? The A is 4 marks, 3 or 4 marks? Yeah, 4 marks. Sometimes 5. B will be 3 marks and C will be 2 marks. Okay? Or 1 mark, depending. Alright, let's go to the next question. We're looking at example 8. And the next, example 9, sorry. On the next page. Example 9 on page 262, we are told A, B, C, and D are concyclic points. What does that mean? Concyclic. Means to say that A, B, C, and D are points on the circumference of the circle. Okay, it's concyclic. Then DOC and BOA are chords. Then we are told that BO and AC are joined. Prove that. So again, we're going with similarity. We must prove that triangle AOC is similar to triangle DOB. So where do we start? We can start by saying in triangle AOC and triangle DOB. Normally the order that is given to you is the correct order. Okay? So what can we say first? O1 is equal to O2. Why? Vertically opposite. Okay. Then what can we say? Angle C equal to B. Why D? Alternate angles. But are the lines given parallel? No, so you can't go. Okay, so it's going to be angle B is equal to angle C. Angles in same segment. It's coming from arc DA or AD. Do I have to write that? No, I don't have to write the arc. Third angle, A is equal to dy, angle in the same segment, or it's the third angle of triangle. If 2 is equal, automatically the third one will be. Okay, you guys understand? If you had written angles in the same segment, you will get the full marking. Okay. Is that enough to conclude similarity? Yes. You'll see me always make those 3 bullets to remind me that I need 3 equal angles. You'll see me do it the same in congruency Y. So we need 3 points in congruency. Okay, to say 3 things when we conclude congruency. Okay. So I can conclude therefore triangle AOC, which is AOC, is congruent, not congruent, similar to triangle DOB. Okay, why? Angle, angle, angle. Alright, are you all okay with that? So what I'm going to do is again, I'm going to take this off here, as I need the space, okay. Again, I want to keep the diagram in focus. So what did you say? What will follow a distance squish? Not so. So let's go with B quickly. So what do we say first before we do anything else? We say that AO over BO is equal to OC over OB equals AC over EB. Why? Yes? AOC. So it's AO over DO. Sorry, my mistake. And then OC over OB and AC over. Right, thank you. And what's the reason here? Sides in proportion, or triangle ABC is similar to triangle DOB. So let's see what they're looking for. They are looking for OB, which you have, OD, which you have, OC, and OA. Is that not exactly? No, it's not exactly like the one. It's not so. So what must I do? Just interchange those two. So therefore, OB over OD or DO, it's the same thing, is equal to OC over OA. Or, A. People, you guys understand? See, any confusion? No. So with that, you should be able to do exercise 4. Out of exercise 4, I want you guys to do the following. Right, the whole exercise, only 4 sums. Alright. So I'll stop the video at this point.